Shilpi?
Yeah, sir, one thing I wanted to be clarify is like what does it mean that if violated, is it like both the convergent validity as well as the discriminant validity is not meeting the threshold, and then we will go for the second order model building, or any one of these?
Anyone. So usually you can try out multiple combinations. You can try out. So for example, if one construct is not discriminant with another construct, what you
Okay,
can do is you can, so let's say two out of the three do not come out to be discriminant. That means they are highly correlated. Then you can model it as a two-factor model instead of a three-factor model.
okay. And sir, in case like our like convergent validity is coming good and meeting the threshold, and discriminant validity is not meeting the threshold,
Hmm.
so in that case also, do we go for second order modeling?
Yes, yes. Because convergence here, we are only talking about items converging on their latent factor.
Okay.
Whereas the second order factor is needed when your these factors are not discriminant to each other. These three factors, they are not discriminant to each other.
And sir, sorry, one more question.
Huh.
If we are not getting the discriminant validity with the traditional method, the method that we have, and we are using, let's say, HTMT or other method, and we are getting that time the discriminant validity. So
Yes.
in that case, should we go
And
for?
yeah, go ahead with the HTML. Yes, absolutely.
Okay, sir. And sir, in that case, should we go for second order modeling as well?
If you are getting discriminancy, then there is no need. Then
Okay.
there is no need. But if you want to model, it is again theoretical. See, that would be answered by your theoretical choice, whether you want to uh, test the relationship with underlying dimensions or you just want to test it with the overall second order factor, right?
Okay. Okay.
Yeah.
Fine, sir. Thank you, sir.
Yes. Ramini,
Sir, in case the convergent validity conditions are not met, then what is the remedial measure? What do,
which conditions?
sir, if the CR value is not greater than zero point 0.7, or if the A,
Yeah.
you
So
know,
then you should drop items. See, when will this go down? When your lambdas are small.
okay, yes.
So you will have to drop items which are having smaller lambdas or poorer
Okay. So
or
now in CFA, we are going to, because
yes.
you said we should not drop anything, even if the factor loading is like point more than 0.3 or 4. It was for one
No,
factor.
I said you may or you may not drop.
Yes. But here we need to drop.
Yes, you will need to drop because your CR is going down. Just like we do it for Cronbach's alpha, right? We say that we will, if there is any item which can be dropped and alpha can be improved above zero point 0.7. If it is already zero point 0.7 and above, you don't do drop items. But if it is below zero point 0.7 and there is an item that you can drop to improve the reliability, you will have to prune it or drop it.
Sir,
Okay,
can
sir.
we have lambdas more than one also?
No, usually we don't. Standardized lambda. See, unstandardized lambdas can be more than one. But
Because the model which we have ran in the EMP2 shows 1.12.
yeah, but that is unstandardized. Let me show it to you. That is unstandardized. So unstandardized lambdas can be anything. They can be anything. But standardized will always should always be less than one. Yeah. Yes, Kishore.
Yes, sir. My question is basically convergent validity means it is within the construct,
Within that, so
and discriminant is between. So
between.
when
So
yeah, so
yeah.
when in case in your sir in the previous diagram, you mentioned that in discriminant, can you put that screen, sir, of the previous
Huh,
diagram?
should I go to the diagram?
Yeah, diagram.
Yes.
Yes. So here, if you see, is there a possibility that AVE temp and there is a difference? Like for example, in one of these constructs is less than R square of x1 x2. Just suppose out of the three, only one is less. Then
Yeah, it is possible. So then you are saying that your construct is your this factor is not discriminant,
correct.
right? So you will now there are two options. One is you go ahead and do the second order factor model, or you can try out you can mix. So for example, let's say EMP does not come out converge or does not come out to be discriminant from TO. So you can create a diagram like this. You can also uh, you can have one factor which is EMP TO combined, and you load all the three items of EMP and all the four items of TO, right? So this is EMP1, EMP2, EMP3, and then you have TO1, TO2, TO3, and TO4. LEX, because it was discriminant, you continue to have three items. And then you estimate another factor, another measurement model with this kind of a model, right? And then test what is the correlation, and then check whether the AVE of EMP-TO combined is greater than R square between the two, and the AVE of LEX is greater than R square between the two constructs. But the problem here is that this becomes EMP-TO combine will lose its meaning. What does this factor really stand for?
Correct.
Right? So usually what I would recommend, if you get even one construct which is not coming out to be discriminant, what we should do is we should go ahead and model a second order factor model. So now we can say, well, this is my leadership model, or this is my leadership factor with three first order dimensions, and we are aware that they are highly correlated, and therefore we are modeling the leadership factor. And for future tests, okay, we are going to use this leadership factor, overall second order leadership factor, to test the relationships uh, with other constructs in our model. So that is the idea of a second order factor model.
Okay.
Sir, I have one question here. We
Yes.
would be saying we would be using second order factor only when we have like some less discriminant validity for some variables, or if we have like a good discriminant validity and we want to.
You can do that. Rahul, would be determined by your theory. But if the data fails, if the analysis, if the AV fails, then you will have to for sure do it.
Okay, sir.
If it passes, then also you can do it. If theoretically, for example, you do not want to test the relationships with individual dimensions, you want to test with the overall second order factor, then you go ahead and model the second order factor and work with it.
Okay, sir. Got it. Thank you, sir.
Yes.
Sir, isn't a multidimensional scale by default a second order factor, or how does it work?
Yes, usually it is a second order factor thing, but it depends on whether you want to model that second order factor or you don't want to model that second.
So rather than using the dimension per se, we use the subdimensions when it is
Yeah.
used as a first order model.
So
Is that what you mean?
then, yeah, so you can also test this model, right? You can also say, well, I want to test the relationship. So I can also do this kind of a model, right? So my outcome I test with my relationships with the 3 first order factors. That is also one option. But if they are having very high correlation with each other, then the problem is you will run into multicollinearity issues. If there is high correlation between the factors. And therefore, if you have high correlation between the factors, you can still go ahead and test it. Okay, I'm not saying you don't, but then you may have problems associated with multicollinearity where each one of they will start canceling out their effect on the outcome variable. So you may actually get non-significant betas here, beta 1, beta 2, beta 3, because you are regressing all three and all three are highly correlated to each other.
Okay.
In
Thank
order
you.
to avoid that, what you do, because they are highly collinear, what you do is you do this. You model one second order factor and then test the relationship with the outcome. Yeah.
Yeah. Thank you. Thank you.